Welcome to Hope Academy. My name is Mr. O, and today I'm going to be going over the practice exam 2 from the ACT website, specifically numbers 4 through 6. Please do watch the prior videos if you want to look at the prior questions. But that being stated, usually I do these questions real quick and then I explain in depth how to do the problem. So I'm going to go ahead and get started. So for number 4. 495. Okay. Bunch of drinks. How many different daily? Oh, okay. There's 3 here. 2, 5 here. 1, 2, 3, 4. So 3 times 2, 6. 6 times 5 is 30. 30 times 4 is 120. Okay. So for number 4, my final answer is I. And now I'm going to explain to you how I was able to get to this answer. So for number 4, when I saw this question, I saw there was a lot of description stuff, and at first I thought maybe that 495 piece was important, but I started realizing that after they showed the menu, which I didn't read through it, I didn't care. The important thing was asking about how many different daily lunch specials are possible. And so this is a concept, at least I believe it's called the number theory. And this is a statistical based question based on number of total possibilities that do exist. And so when I'm doing number theory and working through it like this, I noticed right off there's 3 possibilities for salads, 2 for soups, 5 for sandwiches, and 4 for drinks. The thing that told me right off was that, okay, I need to do is sort of multiply these values because that's how number theory works. Because let's say that if I have, let's say a very simple example is that let's say I have two choices for drinks and 2 choices for snacks. How many total possibilities will exist? I could actually think of the idea that, oh, well, if I try to combine those 2 possibilities with 2, I'll have total of 4 possibilities, or aka 2 times 2 will be 4. And that's why I could multiply these. So I did 3 times 2 times 5 times 4. And I sort of mental math this part. You could use the calculator if you want to, but it will end up equaling to 120. Thus how I was able to get to the answer for number 4. And now to continue on to the next question. So for number 5, I'm going to move this paper out of the way. I'm going to go ahead and get started. So number 5, volume. Okay. Okay. Height. Okay. What's the radius? Okay, we're looking for radius times 8.5. Okay. Here's the nearest centimeter. Okay. So. Do I have a pi? Oh, I do. And then square root that answer. Okay. So for number 5, my final answer is B. And now I'm going to go ahead and explain to you how I was able to get to this answer. So when I was doing this problem, and I'm going to move the calculator out of the way. When I was doing this problem, the important thing in order to do this question is to understand that the volume for a cone is provided in this question. I do want to mention that sometimes it's actually not provided to you. So make sure you have these equations memorized, but that being stated, they do provide it, which is very nice. And they do provide certain key infos, and I do want to note them. So they mention 142 cubic centimeters is the volume. So volume is going to be my V. And they mentioned height is 8.5, which is going to represent my H. Okay, and so I simply did what I set it up right here, the exact equation, but including the H. This was my H, and my volume, so which was my V. Okay, afterwards I just simply did this on the calculator. I imagined if I was dividing these values over and then just solved it, but I will show it to you on paper so that you can see what I was doing. So first things first, so I'm gonna go ahead and recopy the question so it's easier for me to show it right off. Times 8.5, and the first thing I did was I got rid of the 1/3, because I don't like that 1/3 is a fraction value, and I could get rid of it. So that's why I exactly did. So I did 142 times 3, and I got 426. So 426 equals 2, and these cancel with each other, so it'll be 8.5 pi r squared. Duly note that 8.5 is from here. I didn't change the question or do anything with it. Afterwards, I divide by 8.5. On both sides. And so I did divided by 8.5, and I got something like 50.1176 equals to pi r squared. Afterwards, I need to do is divide this pi to the other side also. So I did divided by pi. I got something like r squared, I'm going to write it over here so you can see it, r squared equals to, let's say 15.95 on the calculator, and then I square rooted both sides. Be careful, we're not solving for r squared, we're solving for r. And so I square rooted that value that we just got, and then I got something like r equals to 3.994. But because the question asked me to the nearest centimeter, I ended up just rounding it up, and thus how I was able to get b as my final answer for number 5, which is 4. And that concludes my explanation for this question. So I'm going to continue on to the last question for today, number 6, but I'm going to bring the other sheet so you can see it. Okay, I'm going to go ahead and get started. So boat departs from traveling to oil rig. The oil rig is located 9 miles east. So 9 miles east, 12 miles north. Okay, and this is the departure point. About how many miles is the oil rig? How many miles is the oil rig from the departure point? So this. Okay, so for number 6, my final answer is going to be H. And now I'm going to explain to you how I was able to get to this answer so quickly. So for this particular question, yes, you do want to create a visual, and that's what I sort of did, where I imagined as if this was the city, the Port Isabel, Texas. I started off right here, and then I imagined as if the boat was moving over here, then moving up. So east, then north. If you do mix up east and west, or you mix up north and south, that's perfectly fine. This question did not require you to know that. Just as long as you have a generic idea, that's fine. But don't get too wrapped up on those details, because that's not going to help you solve this question. And so when I was doing this, I labeled 9 and 12. And then the part is that when I saw the 9 and 12, the first thing I automatically thought of was the concept on special triangles. And so how special triangles work is that there's special properties that do exist, like 3, 4, 5, 5, 12, 13, and I believe it's like 7, 24, 25 does exist. But the point is that these are special triangles for right triangles that do exist, where if one side's missing, let's say I have the hypotenuse as 5 and I have 3, I know right off the other side is going to be 4 and so on. But where this particular question is not as obvious. If you look at 9 and 12, you don't see 9 and 12 automatically on this, but I actually was able to visualize the fact that, well, if I multiply by 3 on both 3 and 4, so on this 3, 4, 5 triangle, I will actually get 9, 12. And thus, I knew right off this will be 5 times 3 also, which will be 15, and thus how I was able to get to the answer of H. Another method that you could use in case you do not know that, and you're like, oh, well, I might forget it, I might not notice it, what's another method to make sure I could get it, is the Pythagorean theorem. Pythagorean theorem. It's not as fast, duly note, but this method will still work, where the method basically states it's a squared plus b squared equals to c squared, and thus, because my c squared is missing, this value is missing to find c, I could just do 9 squared plus 12 squared equals to c squared, and then square root that general answer to find c, and that would be my answer again, will end up being H, 15. And that concludes my explanation for today. Thank you so much for watching this video. Please do subscribe to our YouTube channel, like our Facebook page, or follow us on Twitter so that we can continue to make content like this. I hope you have a wonderful day.